Yesterday, I got some error in that coding because I forgot to import this thing. Like from PIL, I forgot to import this in. So from here, we will start. Okay. So just I have already written. So I'm not just. So this test image was actually what we did yesterday. We opened one image online, like online we searched one glaucoma image and we took this as test image, as test.jpg. So we have taken this thing as a raw image, then we just resizing it as 224 cross 224 and divided is 255 for making is a grayscale. And we are predicting this thing what we have prepared yesterday, the model. Like our model was this. Perhaps you remember, like last day we did this model. So this model, just run it. So we are getting some prediction value. It is 0.091, so 0.0 something. So using that, so we have two classes, class names like glaucoma. If this prediction value is near to 0, it will give output glaucoma. If the value is near to 1, it will give us the value non-glaucoma. It is, if the value is near to 1, then we will get the output non-glaucoma. So it is just, we are just rounding that point value and converting to integer and predicting the class, like class name, this prediction, this integer. So let's check what is, I have already done it. So now again we have run and we got this, it is glaucoma. Now we are changing this raw image. We are taking some other image, like this raw image I am just uploading from my Google Drive. So this is actually non-glaucoma image, non-glaucoma folder. Under that, this image. So let's check what we are getting the output. So the predicting is 0.9. So it is near to 1. So obviously we'll getting the output as non-glaucoma. See, we have got the non-glaucoma. So these are the last day stuff. So perhaps you remember, all of you remember, like steps. So first day we covered the neural network and term deep, and last to last day we covered this thing. The second day yesterday we covered convolution neural network and hands-on this application on computer vision tasks. The tasks for the recurrent neural network and some hands-on application on natural language processing. Okay. So a brief overview, like what was the, like why we need like this type of things. Like at first we learned neural network, then convolution neural network, then today why we learn the RNA. So in brief or very basic term, in neural network, if the input, there is the input is like is a 1000 cross 1000, then in the input layer will have 10 to the power 6 nodes. So get rid of this, we just use the CNN. There are lots of other advantage as well. For shortage of time, we can't cover those things. And what are the problem of CNN and why we need the RNN? Because the RNN works good for sequential data. RNN works better for sequential data. What is sequential data? For example, like what I am talking now, like what I am talking. So it is on speech, like speech signal, you can say, like speech. It is sequence, like each time T1, T2, T3. So each time we are getting some data, speech data, and if we are somehow converting to some say language. Natural language means like the what human are saying, like natural language, like English, Bengali, Hindi, like this type of language. So this is called like natural language. Like for example, today we'll do some work on natural language English. Okay. So and we will perform some tasks on natural language processing in short NLP. So at first I will give some brief overview of sequential data, then RNN model, then we will go or jump to the coding part. Okay. And this NLP language related coding takes too much time. So I have already written few lines of code. Otherwise, like it will take too much time, like 1 hour. So some examples of sequential learning or examples of sequential learning or at first sequential data. What are the sequential? So at first, what I have already told, speech recognition. For speech recognition, it may be used. So the input is say speech some signal like some waves like signals, and the output is some say code like say welcome or say, so it will type welcome to this say. So this is the output. Some other examples say music generation. So if I give some say, for example, I give the input as sad songs. So it will generate automatically generate some music notation like this notation perhaps, like this notation. It will generate some music. And sequential means time sequence. That is time sequence. Or another example say sentiment analysis. What is sentiment analysis? So for example, I have watched a movie and just say to my friend that this is a bad movie, like very bad movie or like that. So output is, so the output, it is say we are saying as a negative review. Negative, or if I say it is a good movie, so it will give us some positive. So in biological domain, DNA sequence analysis. So there are some set term ATCC, like GS sequence. So if we want to predict some what are the some diseases or JNSR, sorry, I don't know very much about this DNA sequence and this is biological biology. But suppose we want to extract few like extracts where the anomaly portions, anomaly DNA sequence. So that portion we can grab. That is the output, like whether there is any anomaly or any disease, those types of things. And some other things say, and machine translation. Perhaps you all know the machine translation, because like if I write say I eat rice, say in Bengali, some Bengali translation, I mean say or some video activity recognition. So everywhere where the time or the sequence is related, we can use that RNN. So there are very much too much applications. So I am naming some few. So video activity recognition. Say we are taking some video frames. Okay, some video frame. Say one person say run. Sorry. So video frame. So what is the activity? Say it is running or say swimming. So like these things or video activity recognition. And some NLP related tasks, name, entity recognition. What is the name entity? Say I write my name is say Chandra. The output will be where is the like name entity. So it will mark like my name is, so it will mark in red Chandra. So it is called name entity. So today in the programming talk, we will implement these things like sentiment analysis. So I am assigning that task, then we will cover some theory portion of the RNN or recurring neural network. So in the programming tasks, what we will do, so perhaps you all heard or know the IMDb database. It is the movie database. Yeah, this is the, say for example, IMDb database. So this movie Godfather, some people are giving some review. So we want to put like input that this review input, and we want to get the output as it is a positive review or negative. So if I put these things, it will give me positive review. Another movie name. So if I put these things, this review, the input, it will give me the output negative. So we will perform this task. Okay. So here our output will be some sequence of sentence and input will be sequence of sentence and output will be positive or negative, like 0, 1. So now what is RNN or recurring neural network? We will peek into the RNN, but not very much details due to the shortage of time. So from our like past class, we know the neural network. Neural network things we all know. So here suppose X1 is a feature. Okay. It will go, suppose this box is our, say, for this time being, say, neural network. And we are getting some output. Perhaps you remember we are getting output y hat. For X1, we are getting some y hat. So I am giving one example, say, I rice and curry. Okay. So for this time being, X1 is my I, these things. It is X2, X3, X4, X4. I am giving one simple example. Okay. So this will go to another neural network. This will go to another, like this way. Neural network, say one neural network. What the output will be? Something, say Y2 had, Y3 had, Y4 had, and Y5 had. So I want to translate. I want to translate these things. Say I means say Ami. Say it means I. Say rice. Ah. It's Bengali language, so perhaps some of you don't know Bengali, it does not matter. So, okay. So it is translating actually. So what is the internal thing? So this I, here it is I. That's why it is something high. If it is some U, then it will be say some like U, like second person. It will be cow. So something different. So this thing, these things is dependent on the previous one. So this, there is a dependency. So every sentence there is every word there is a dependency. And here, instead of neural network, we are using some RNN block. Some RNN block. So in for the simplicity, say this is X1, this is A1, this is A2, this is A3, this is A4. So this A1 is dependent on this, and here it is, say suppose the starting things we require. So this A1 is dependent on A0 and X1. So A1 is a function of this A0 and X1. Similarly, A2 is function of this X2 and this A1. A2 is a function of, like in the first class, I told you that neural network is nothing but a function. So A2 is a function of, say, A1, and one more thing, A3 is a function of, say, A2 and X3. So there is a dependency, like this Y3 term is dependent on this, because like, and here on this connection should be there. And Y1 is the output. Here is one connection, like from A1 actually we are getting that one, there may be some function. Some activation function. I'm not going into detail of the activation function as I told in the first class. So there is some function. So here also Y1 is some function of A1. Y2 is also function of, say, A2. G is some activation function. Y3 is some function of A3. So by this thing, so Y3 is dependent on the past and present sequence. This past and present unidirectional. If this is unidirectional, so Y3 is dependent on X1, X2, and the present sequence, present input X3. And there is another term is called bidirectional RNN. ERNN. It is also possible there is another connection like this one. So in this case, Y3 is also dependent on this 2 and this present as well. So in the bidirectional, the current output is dependent on the past, present, and future. And the only RNN, it will be dependent on past and the present. And another thing, like, perhaps I mentioned in the first place, like neural network, something is a function of, say, you have, say, two node X1, X2, and output is just suppose something, maybe multiple layer. So multiple layers, like if it's there. So this one is function of X1, X2, and this thing, this layer is this layer is function of these things. This layer, in this layer, the output will be function of these things. So it will be deep, going to deep function. Okay. So we may put like multiple layers, like yesterday's class, we put, I think, 3 convolution and 3 max pool layers. So it may be deep. So it is nothing but a deeper function of this, then function of this, like this. Okay. And another thing, like how we'll represent this, like I in a numeric value, like I is here something like what sequence. So for these things, we have to define one dictionary. So, or in NLP term, we are saying as a vocabulary. So suppose in my vocabulary, I have say 10K words. In commercial things, it may have some 1 lakh or 1 lakh, 1.5 lakh words as well in English. So vocabulary. So here in the dictionary, suppose a word as a something, say dot dot dot, something say as, something say back, like this say zebra. Okay. So here is also say I in dictionary form. Suppose this I is suppose say 5001th position, there is I. So we are representing one vector. This I corresponding to 1, except all the other position we have to put 0. Okay, 0, 0, 0. So only one position it is 1. Say for here say it is say it. So it may be say something say 4005 position. So it corresponds to this 4005 positions. It is 1. Remaining all the positions are 0. So there is a terminology. It is called one hot vector. We are converting that word to a vector, and in this vector only one position has the numeric value 1, other position it is 0. Okay. So in this way all this like word will be converted to one vector. Now I am coming to our IMDb word, like programming word. So here perhaps you remember the input is some word. Okay, some word. So input is this is not not a good movie like this. So this thing. So our x1 is one hot vector, x2 is another one hot vector, x3, x4 dot say xn. What will be the output? Here the output is not these things. Not every position something is coming up, right? Only the output is 0 or 1. 0 means it is a negative review. 1 means a something positive review. Some negative review or positive review. So how we'll map these things to our RNN? So obviously there is something what we will map. We can map it here also, or another way. There is another way, like make it simple. These things. What is there? Like this way. This one say A1, A2. Initially some A0 is there. You can put A0, you can do 0 as well. So what will be the output? These things. We can simply put this like here as well. So this input, this RNN, these things will be function of that, like y1 had something, y1 had and a1, sorry, not a1, x2, this thing. This one also, like we can just connect these things here. We'll perform this one. And there are this RNN, in the RNN, there are several RNN architecture. For example, that we call GRU. There is one old and famous architecture, GRU. The full form is Gated Recurrent Unit. And another, the most famous is LSTM. It's called Long Short Term Memory. And we can also use some bidirectional way. Then there will be one term is coming the LSTM. So this will be bidirectional. So like again, thanks to the like framework, so we don't have to go into the, for this webinar, we don't have to go to the internal part of the LSTM. Only one simple code LSTM, some function is sufficient. But in our coursework that you already know, like you already know, we offer like these courses. So in these courses, like in this, particularly in this course, like MTech in computer science, specialization in data science and machine learning. These courses we cover the internal those parts. Okay, it will take time actually. There's model really it takes too much time. So just go to the coding portion. I've already written that thing. I will just explain this. So this is simple. This is simple. Some importing things. Okay, just import. Then perhaps you remember we work on Google Colab. So you need some internet connection and some Gmail account. That is the basic requirement. And we put all the things on the cloud. And this data set is really huge. So in the Keras data set, we can load this data in this one. So one by one. Okay. So at first import some TensorFlow, NumPy, and this sequence and this array. Then, as I already mentioned, the size of the dictionary or the vocabulary is we have taken 10,000. Then we are loading that data from Keras dataset imdb.load data, and number of words equal to say vocabulary size. This is 10,000. And we divided something like xtrain. Xtrain means those input sentiment or sentiments or review. In xtext also the sentiments or review means in those reviews some sentiments are like attached. So that's why it is called sentiment analysis or IMDb sentiment analysis database. And in ytrain we have actually the label. Label means like positive or negative those reviews. So here we have put the 0 means negative and 1 means like positive. So simply and we can like include these two lines also. So it is if some like logging error is coming, it will like disable those things. So shift enter or just click here to run these things. Then come to this portion. So word index. Word index means what we have written here, like this say it. This say index is 4005. So I is indexing is for example 5001. These are those index. And here are some basic word index. Pad, start, unknown, unused. What is this thing? Like start means starting position of that sentence. Unknown means suppose some word are not in the dictionary. Like suppose like something, say for example, if I have some word like say in Bengali some name, say my name, Chandra. So it is not in dictionary. So instead of this, machine will put say unknown or UNK like these things. And what is padding? Say my fixed, I have to fix the review site. Say I have fixed the review site, say 10. And I have put some review. This movie is not good. So what it will be convert? So here the number of words 1, 2, 3, 4, 5. So previously there will be 5 words, 5 pad, like let's say pad. So padding is there to make this input at 10 bit long, 10 word long. So then something say start like then this movie is not good. So we will come to this. So unused obviously as the name suggests. And reverse word index, like in the reverse, like from the lower portion to upper. And we have to decode those review into the and input this text and getting the reverse word index. Okay. So this is for like performing reverse word lookup. Then we just run these things. And in this all reviews, in this list actually, we are concatenating all the reviews like xtrain and xtest. NP is the numpy short form, numpy concatenate, xtrain and xtest for concatenating test and training data sets. And here is this is written that we are getting the maximum review length and the minimum review length. Suppose like for example in this example, too much long review. Okay, number of word, and some person is writing say some small review. This is a good movie, like only say length. This is good movie, only length 4. So we are getting the maximum and minimum review length, and this mean means average. We are averaging those all the reviews. Then this we are if we are from here. So here, for example, the maximum review length we are getting 2494. The minimum review length is 7. Mean is this. And machine readable review means like there are some indexing like 113, 219. Those indexing word that we mentioned like here. That index. And review sentiment is 0. 0 means, and here human readable review for our purpose, like we are taking one example of xtrain 60th. Actually this is 61th 61th training example. Review text say here it is start. I saw at the something unknown. There is some unknown word, some citing investible name. So this way we just convert these things to machine readable review. Now, for our tasks, like to make it simple, we are just fixing the review length. Review length as 500, or you can take it say 200 as well. So fixing these things, all the review will be fixed, and we can check like here, like 500. 500 is the review length size. And the shape of the training review data, we have the training review data as 25,000. We have the data, and the test class data, test also we have 25,000 data. Thanks. Now our actual model. Now here you can see some example like pad, like because this 61, that thing is not human, that not so initial portion pad these things. Yeah, after that it is start. All the sorts of these things. Now the model like similar from as per the last class, from TensorFlow we have to import TensorFlow class. We have to import the model and as well as the layers. Like last in the convolution class, what we did. Here into the sequential portion, we just added those layers. This is one way. Another way is just like after declaring the sequential object or sequential model, we just add later on. Like we have already declared, then we can add one by one. Add one by one. Like at first, like layers dot embedding, we have to embed those words into the vocabulary size. Then the output dimension here. I am coming to this. Output dimension is 32. Input length is the review length. It is, we have already decided, it is 500. Then there is a concept of dropout. Dropout means, this is some theoretical. Dropout means, suppose you have some one architecture, okay, this one layer nodes, okay. So some weights are associated, all the things, weights are associated. So there are W1 to something, so WN. Here some weights are associated, connecting. This is a layer 1, layer 2, layer 3, layer 4, layer 5. This is my layer 1. So all the connection is there, and you are getting some sort of say output, some binary class 2 or say multiple class 2. So it may be possible one connection is in a better, but we want to train our model. So overall it is impactful, or overall it is training in a good. So what we will do, we will arbitrarily drop some connections, or in the better way, we are arbitrarily dropping some nodes in a layer. So if it is say a dropout, here the dropout rate is say 0.5, we are dropping like 50% of the node, so that the connection associated with these two nodes all are deleted, so that the other connections or the other nodes are getting some chance to train in a bit. Yeah. So here the dropout rate, here the rate is 25%. And after the dropout, here is the main thing. Here we are using our RNN unit as LSTM. And in the LSTM, we are using some unit 32. And again, we are using one dropout layer. And at last, we are adding one dense connection with sigmoid activation function. And at the output, we have the unique one. Here you can see, like embedding these things is the 500, then 32 output dimension, then LSTM 32 dropout, and the last thing, it is the one. So it will give us some probability value. Based on this, we can like classify whether it is like positive or the negative. And here the loss function, again, as per the last class, this is the binary cross entropy. Binary cross entropy is nothing but as per the theory. Suppose we have say suppose two class, say output will be say y1, y2. Okay. So the loss function, loss will be y1 log y actual is this y1, and predicted output is y1 hat and y2 hat. So it will be y1 log y1 hat plus y2 log y2 hat. And overall there will be minus because it is entropy. In formula, the entropy formula is minus say something p log say p hat. So for binary cross entropy, we have two classes. And optimizer, we are using Adam. I am not going into details of the Adam. And in the first class, what we did, we just learned the theory portion of the gradient descent and did some program of the gradient descent. But Adam is At Adam is the like one better optimization technique. And metric we are using accuracy. And here we are printing the model summary. So model summary is this model total parameter and trainable parameters are same. And if we draw this diagram, we like use this same like syntax like last day. So draw the model like this, input here this, and output we're getting like one predicting value. Now I'm just running this. After this I am explaining because it will take. So model.fit, we are fitting that model using X train and Y train. Here batch size is 256, means at a time it will take like 256 number of samples at a time. And epoch, for this class I am choosing the epoch size is 3, but you should take like it is like too much, like say around 100. And validation speed 0.2 means like train into validation, it will be say suppose in the ratio of say 80-20. Like yesterday's class, we did this manually train and case, but today we are taking arbitrarily some 80-20 ratio. Verbose is this like dot it is coming. It is just printing the processing. This designing this. This arrow is going due to this verbose. We can see like how much it is written. So after epoch 1, the training loss, it took like 480 millisecond per step, and the loss is 0.6 training loss, and training accuracy 0.66, validation loss these things 0.44, and validation accuracy is 0.79. So see, from the first epoch to second epoch, the accuracy is better. So we have to check like how much epoch is required. Like we may run up to say 100. So maybe the accuracy if constant like in 50 to say 60, like epoch if it is constant, then we can choose up to 70. So it will save a lot. Just so finally our validation accuracy is 0.88 or 88%, but you can see this validation loss is 0.29. So as per our first class, I told you that our objective is to minimize this training loss. So here the training loss is 0.21. So this is not good at all. So we have to train more. Due to the shortage of time, I am just keeping as epoch thing. I think Rohan yesterday covered like precision recall, those confusion metrics. We are just printing these things, like printing the classification report, nothing else. It will take time because we are grabbing all those X tests, like predicting all those X tests and getting the classification report on the Y test and predict. So here in this time in the So our accuracy is like F1 score, it is 0.87 or 87% around. And now I have written some few reviews like say this review one. So this gave us some accuracy on the base of those data. Now we want to predict our own data. Suppose we have typed this like this was a terrible film with too much violence and I walked out halfway through. So you can understand that this is some sort of some negative review. So let's check whether we are getting the negative result or not. So these things review lower means like in some portion there are say capital letter is TI. So I have done all the things in the lower portion and splitting the word based on those spaces and predicting the like emotion like sentiment using model.predict, and this is we are printing the actual review what was written, some raw predictions. See it at first we have to run. we are getting the prediction value is 0.09. So it is near to 0, we are getting negative. The next example, so I am commenting these things. The next example is, this is the best film I have ever seen, which is a great and fantastic, and I laughed. So it is some sort of positive review. So let's see what I am getting actually, what we are getting actually. Okay, we are getting predicted class positive. So it is positive review because some prediction value is near to 1.9. Let's check the next one. Next one is an awful film like this thing. So obviously it will give us some negative review. Now these things, this terribleness, like terrible, like something. What is there? So obviously, yeah, we are getting 0.04 minus the negative. So up to this we have done. So now some question answer session. So just type your question. And my email ID is I think, if further, if you have any question, just email. And if you want like want to know something more, more like you can also email me. More means like related to what we are doing, our research. You can join us in some research project as well. Attend some other webinar sessions, some internships. So throughout the day, we are offering multiple things. You just keep an eye on our Facebook and YouTube page. Just Google it, easily find. And some other anything research related or academic related query, like we will try. Like the multiple faculties. If I don't know some answer, I will forward those things to others also. Can you have any question? Just write in the question answer panel or just in the Q&A section. In the programming portion or the theory portion. I did not type it today because it is taking too much time. Unnecessarily, we are keep waiting our next speaker. So. Any question?
So welcome everyone to CS231N. I'm super excited to offer this class again for the third time. It seems that every time we offer this class, it's just growing exponentially, unlike most things in the world. So this is the third time we're teaching this class. The first time we had 150 students. Last year we had 350 students, so it doubled. This year we've doubled again to about 730 students when I checked this morning. So anyone who was not able to fit into the lecture hall, I apologize. But the videos will be up on the SCPD website within about 2 hours. So if you weren't able to come today, then you can still check it out within a couple hours.
Any question? Or any like any suggestion, like any question or suggestion, like what you want to learn more in this, like future webinars, any suggestion? From today's class, any question? Then I can, if you don't have any question, I am just elaborating on small topic that I did not get time to cover. Activation function. So activation function means, like for example, what we have example as sigma. Okay. So sigmoid function is looks like this. Sorry. This is 0.5. And this portion is near to 0, and this portion is near to 1. So when there is very, and perhaps you remember that during the back propagation, the sigma dash x, it is becoming sigma x into 1 minus sigma x. So its derivative will look like this. So it will be very small value, 0.25, it will be the highest. So when we are back propagating the error, remember this is gradient sigma dash x. So we are back propagating in the gradient descent. In the gradient descent, we have to multiply this point value. So maximum is 0.25. So some values are coming say 2 into 0.2. So it will reducing gradually, like 0.2 into 0.2 is 0.04. So if the architecture is too much deep, so there is a possibility when the gradient is going in the initial layers, there is a chances of vanishing that gradient. This problem is called vanishing gradient. To get rid of this problem, or to introduce, we are taking different types of functions. Say for example, ReLU, is full form rectified linear. How this curve look like? This curve look like this, then this. So what is the function? Function is 0 when x less than equal to 0 and 1 when fx equal to x when x greater than 0.